Here I'm going to discuss about the linear integrated circuit and its applications. What is an integrated circuit? It's nothing but fabricating of the passive and active components onto a single chip. We are going to call it as an integrated circuit. Coming to the advantages of integrated circuit, that particular IC is available in the form of a small chip. So miniaturization is one of the advantages of ICs. Since the processing of IC is batch processing, comes under the batch processing, the cost per chip is going to be reduced. Coming to its reliability, since we are not going to have any soldered joints, so these ICs are more reliable compared to the discrete components. And its functional performance is also improved. And the operating speeds are also going to be increased. Since the size is very small, the amount of power consumption is also being reduced. Coming to the classification of ICs, we can classify the ICs into different categories depending upon the number of transistors or gates that we are going to fabricate onto the single chip. So we can classify that based upon the number of transistors as small scale integration, where around 3 to 30 gates or approximately about 100 transistors are being fabricated on the single chip. We can give the examples for this particular SSI family as the logic gates, flip-flops, etc. Coming to the medium scale integration, where around 1000 transistors are being fabricated on a single chip, and we can give the examples as counters, multiplexers, adders, etc. And one more category, we are going to call it as the large scale integration. Around 1000 to 20,000 transistors are being fabricated on a single chip. And there we can give the examples as the 8-bit microprocessor, random access memory, and read-only memories. Coming to one more categorization, the, called as the very large scale integration, VLSI. Number of transistors that are being fabricated on the chip ranges from 20,000 to around 10 lakhs of the transistors are being fabricated on a single chip. So 16-bit and 32-bit microprocessor comes under this category. Next advanced version to VLSI is ultra large scale integration, where around 10 power 6 to 10 power 7 transistors are being fabricated. And we can give the examples as the special microprocessors or what virtual reality machines or smart sensors comes under this category. Next configuration is giant scale integration, GSI, we can call it as. Around 10 power 7 transistors are being fabricated on a single chip. Coming to the classification of ICs, we can classify the ICs broadly based upon their operation. We can classify it into the digital ICs and linear ICs. Linear ICs will take the continuous signals or analog signals as the inputs and produces the output. Maybe it may be analog or it may be digital. So we can operate the linear ICs in the linear applications as well as in the non-linear applications. Coming to digital ICs, which accepts the inputs as the digital signal, that is zeros and ones, and produces the output also in terms of digital signals. We can also classify the ICs based upon how they are being manufactured. So ICs are classified it into based upon the manufacturing and based upon the transistors that we are going to use for manufacturing. We can classify the ICs into monolithic ICs and hybrid ICs. In monolithic ICs, all the passive and active components are being fabricated on a single chip, whereas in hybrid ICs, The active components, they are separately fabricated and then they are interconnected. So these monolithic ICs are again classified it into bipolar and unipolar based upon the devices that we are going to use. So bipolar, nothing but where the conduction is because of both the minority and majority charge carriers, and unipolar, where the conduction is because of only the majority charge carriers. So if the ICs are manufactured using the PN junctions or dielectric isolations, we can call it as the bipolar. And if the transistors that you are going to use are of MOSFET or JFET, we can call it as the unipolar. Coming to the IC packages, these IC packages are available in three different forms: the metal can, the dual-in package, and flat pack. So metal cap, we are going to see the example. We can take it as the discrete transistors that we are going to see. BC107, you can give one of the example. And this dual-in package means the pins are arranged on either side of the IC. And in flat pack, the we are going to have the arrangements of pins on either side, but the base or body is of flat type. Here, one of the linear integrated IC is nothing but IC741. We are going to call it as an operational amplifier. So this shows the symbol and pin configuration of IC741. So it is available in the form of a dual-in package with 8-pin DIP. 8-pin DIP. DIP stands for the dual-in package. Coming to the pin configuration. So first pin is the offset null pin. Second is the inverting input. Third is the non-inverting input. And fourth is the minus VEE. Fifth one is the offset null pin again. Sixth is the output. 7 is the plus VCC and 8 is the no connect. So offset null pin means we are going to use a potentiometer between pin 1 and 5 and we are making the output voltage as 0. Offset voltage means whenever, even though we are not going to give any input to the operational amplifier, still we are going to get some output voltage called as the offset voltage. To nullify the offset voltage, we are going to connect a potentiometer between pin 1 and 5. And by changing the wiper of the potentiometer, we are going to set the output voltage as logic 0. Coming to the second input, this op-amp 741 has two inputs called as the inverting input and the non-inverting input. So second pin, we are going to call it as the inverting input, and the third pin, we are going to call it as the non-inverting input. Power supply that is needed for this particular 741 is dual power supply, the plus VCC, which is connected to the 7th pin, and minus VEE, which is connected to the 4th pin. Generally, 12 volts or 15 volts can be used as the power supply. And the 8th one is the no connection. On the left-hand side, we are going to see the symbolic representation of IC741, showing the inverting input, second as the inverting input with the negative sign, and the non-inverting input, pin number 3 with the positive sign. 7th pin, nothing but plus VCC, shown by the positive sign, and minus sign, nothing but the 4th pin, called as the minus VCC or VEE.